Okay, good evening. So welcome to this session on Open Policy Agent. So Open Policy Agent being one of a class of things we call policy engines, which we can use for managing policies in our IT stack, and in particular on Kubernetes. Just to get going, so yeah, you don't want to know much about me. I'm a Brit, but I'm based in Grenoble in southeast of France. Trainer consultant working with ITGilde for a few years now, doing Docker, Kubernetes, Terraform and security trainings. I'm also the world's worst meetup organizer, at least I have been since COVID came around. That's my excuse for the moment. Let's get moving on that. And so grab a seat. This is the workshop joke, okay? I'm not hearing you, Pascal.
Yes, I'm just listening. We'll make the crowd sounds.
Okay, so yeah, let's just start looking at policy engine. What it is, what the need is for a policy engine. Before we move on, I should say. So look at policy engines generally, what they're about, then specifically about Open Policy Agent and some of the tooling around that. We'll look then at some example policies for Open Policy Agent, which uses its own policy language called Rego. Open Policy Agent is a general engine, works with not just Kubernetes. Nevertheless, I'd say the main focus of the session, nevertheless, will be on integration with Kubernetes. We'll look at that next. And then we'll look at how we do that with what we call the OPA Gatekeeper, okay, through these constraint templates. And then we'll look at some of the tooling coming from Styra, the company who created Open Policy Agent. So OPA is open source, but of course Styra have their own product around that project. So we'll have a brief look at that. Okay, so why policy engines? Well, of course, modern IT solutions are now building them around cloud-native technologies, whether in the cloud or on-premise, and that's bringing more software and components, more complexity. The need for security and general checking of configuration and so on is more important today. Okay, now, it's not that practical to use separate checking for each individual component, each platform we might be using, especially if those are built into the platform. This idea of a policy agent, a policy engine, is to have some external engine capable of managing policies, applying them, and then across your whole IT stack, or just your Kubernetes cluster, depending on the engine you choose. Okay, so yeah, policy engines allow you to create a set of rules. Again, it can be for more than one platform, and we can evolve them independently of the platform itself. And those policy agents may be open source. We see there's quite a selection of open source ones. But this session, its focus is almost completely on OPA, Open Policy Agent. Nevertheless, I see this as a prelude to a training around policy engines, and I would like to do further sessions looking at other policy engines. Okay. And then they might be platform specific or not. So just as OPA is multi-platform, there are others. And I'm thinking in particular of one called Kyverno, which is specific to the Kubernetes platform. And that has advantages and disadvantages. Okay, let's first look though, what sort of things are we looking at? How would we use these policy checks? We can of course use them for static validation, which is basically taking some existing configuration files, and before we start using them, maybe before we feed them into our CI/CD pipeline. applying our policy rules and basically seeing if these comply to the policy. Okay, so this might be applied to Kubernetes YAML JSON manifests, for example, Terraform configurations, or many types of configuration. We'll see a little bit later. And then, yeah, once you have that as a tool, so in particular, there's one called ConfTest, which is pretty useful. You can then integrate that into your CI/CD pipeline, and you can do these policy checks early on, because these are static validation tests. You can do them before you actually start testing. Okay, so you have this shift left on those checks. Then we have dynamic checking, and this is really where OPA is really quite largely used as an entity. So typically you would have some sort of gateway which is managing incoming requests to a system. And these gateways would hand off the responsibility to the external policy engine to decide whether a particular request is valid, whether it should be let through or not. Okay. And so we can have essentially validating policy rules where we actually enforce them and allow or deny the API request. In this case, it's the policy engine which makes the decision to allow or deny the request. It's the gateway that actually enforces that decision. Or we could just have auditing of the policies. So we let the request through anyway, but we log that this is in violation of our policies. And there are also types of rules, mutating rules, where if we determine that a request is not conform to policy, we can have some logic that will actually modify the request and then allow it into the system. Okay, that's a bird's eye view of policy engines. Let's look a little bit at OPA. So OPA has been around for about, I think, 5 years now, created by this company called Styra. With OPA, we use policies defined in its own DSL, its own language called Arrego. And Styra also produced their own DAS product, this declarative authorization service, which is very similar to OPA, the open source project, but it's, I would say, more robust. It's designed to be operated at scale, I say with real focus, in particular, on the latency of requests. Okay. But there are also many open source tools and third-party products built around OPA. As I mentioned, you can apply it to the whole stack. So, the obvious thing is over on the left there, Kubernetes running some microservices. You might be using it for the Kubernetes platform itself, so determining what resources can be created in your Kubernetes platform. We'll see how we can invoke OPA during the admission control of the API server. And we could also use it for the individual microservices, so for their API traffic, okay, independently from the Kubernetes API traffic. And then all the other elements that could be parts of your CI/CD pipeline, maybe running the static checks. For example, we could be running it on whatever infrastructure as code tools we're using, Terraform, CloudFormation, whatever. We could be using it for validating some database schema or database authorization, and so on. OPA itself is available in different forms. Well, OPA itself is a static binary, but it also has a library. Okay, so we can use it, the CLI tool, we can use it for checking, testing policies themselves, or we can use it to set up a REST API server against which we can make JSON requests. And we can also use it as a library. There's a Go library, so we can integrate that directly into our Go code. An advantage of that would be that you would have less latency. You wouldn't have a network connection to get through to the policy engine. Another rather interesting feature with OPA is that we can compile our Rego rules down into WebAssembly. Okay, so we'll see how we can load that into some gateways. Another way of being able to dynamically load policies into a running platform and also take advantage of low latency. Okay, there are some other free tools from Styra. So the Rego playground we'll look at in a moment, how we can play with the Rego language in a browser environment, experiment with that. Pretty nice environment. There's a VS Code extension, just facilitates working with Rego code as well. This is, I'll go quickly over this. This is just comparison with some of the different ways of using OPA. So the like the no-brainer way, in a way, is accessing it as a REST API, in which case it is a separate server. Okay, now that could be running externally to your platform or alongside it, or it could be running as a pod in the Kubernetes cluster or as a sidecar container, which would improve the latency. Or we could be integrating as a Go library into our application, or even it's work in progress, but if we have a WebAssembly runtime in our code, then we can dynamically load policies. Okay, the Rego playground, we'll look at this in a moment, so I'll skip quickly over this slide. Okay, and I just planned that now, so I don't know my own schedule. Okay. Oops. Okay, so this is the Rego playground. So it's actually started out with some example code, very, very simple. Okay, on the left, obviously, you can see the Rego code. So we specify a package for the code, specify some default values here, and then here, this hello clause, this is actually a policy rule, okay? So what we're doing is we will receive an input message, and you can see over here on the right, the pane, which is the input. So you can define the input we can use against this test code. So we assign that to this local variable m, and then we check if m, so the message, is equal to world. Extremely simple example, and we can actually evaluate that. And for some reason, that's not evaluating. Brilliant. The demo effect. That is strange. Let me just get rid of that. Okay. We have a page loading problem there. Okay, that looks better. Yeah, there we go. Okay. So we can see here, found results. So this clause hello, we'd given it a default value of false, but the way this works is with this logic. If all these statements are true, okay, we basically go serially through these different statements. The first one, which is false, and this clause exits as false, okay? But if we get down to the end, then we'll actually set this value of hello to whatever we've set here, okay? And so in this case, because our message had the value world, which you're testing for, then we return the value hello set to true, okay? We can see here as well, quite important, you can see that latency is an important thing here. Even in the web interface here, we show how many microseconds it took to evaluate this very simple rule. Okay. And quite nice to use. Over here we can see some other example queries. Let me go to a simple Kubernetes hello world. So now you can see the input pane is much more elaborate. This is representing what the API server would send to OPA if it was configured as an admission controller. Okay, and so here we have a request. We can see the kind in the request is a pod, and somewhere basically this will be creating a pod. We don't see explicitly the nature of the request, but we do see the parameters. The rules over here we have. So basically we're going to do a deny if a particular label isn't set, and in particular the label, let me see, do we give, the label has to have the key cost center, okay? And then we do some pattern matching to make sure that the value for that label corresponds to this CCC code minus something, okay? So if I evaluate that rule already on this data, we can see we have a cost center label, but it's set to fake code, so of course this will fail. We evaluate that, and we see that the deny clause, what happened was it went through, it first sets the value of the label, okay, from the key cost center. It then checks, does this start with CC code? Okay. Now we're actually inversing this. We're saying if it doesn't start with CC code, we drop down to the last rule. Okay, and the last rule is simply setting the message value, in which case deny is set and we return deny with the value of that string. So cost center code must start with CC code. Okay. And just to prove the code does work, let's put change it to CC code hello, do that again, and error occurred, well done. I had this yesterday. It seems to be picking up some funny characters. It's because I've selected code on the left, it looks like. Okay, let's try again. Okay, that was it. And this time it returns deny, but the actual value is empty. Okay, so you can see the playground is a very nice way to play with possible input data, test out your rules. There's also a middle pane here, data, which I don't seem to be able to open. It's actually empty. What we can do is we can put extra data there, which represents other information about what is in our system. Okay, we'll see in particular when OPA is integrated with Kubernetes, we can select, we can actually synchronize data and inventory of other resource types. Because the point is, we'll see that when we use this as an admission controller, we receive the full request JSON of the request, but you don't necessarily know, we only know about this resource that we want to create. We don't know, for example, about other existing pods. We don't know about namespaces, okay? And so the data section allows you to actually build up an inventory of other resources on the system. You have to configure it to be able to do that, but that's another useful feature. Okay, let me head back to my slides. Okay. So I mentioned there's a VS Code extension, so obviously you have nice pretty printing of the JSON, the Rego, and you can evaluate rules there. I'm not going to demonstrate that. I will be too slow. I'm not a regular VS Code user. Okay, otherwise there are also some third-party tools built around OPA as a library. So Confites is a pretty nice one done by Gareth Rushgrove, the previous Docker employees. Really nice tool, allows you to configuration checks on different formats, because OPA itself only operates on JSON. Okay, Confites use that as a library, but it converts other configurations. So, for example, I do have a demo of using Conf-det with Terraform, for example, and in that case, it reads in the Terraform HCL, HashiCorp configuration language, converts that to JSON, and then passes that on to the OPA library. Similarly, with a Kubernetes YAML manifest, that's very easy to convert directly to JSON. There's a company called Fugue, doing a couple of tools, Frago, which provides an alternative to the upper command line tool with an enhanced REPL, for example. There's a tool called Regular as well for doing checks on Terraform. Again, they've built that around OPA. Okay, let's look at some example policies. We've seen a few. So at a high level, what are sorts of things you might want to do with OPA? So for Kubernetes, one thing we'll see later that the pod security policies are something that are now deprecated in Kubernetes since the 1.21 release, and they will go away in the 1.25 release, which will be in about 15, 16 months from now. There still will be some security policies within Kubernetes, more basic, simpler security policies. The form of that remains to be seen. First alpha will be in the next release out in August. But if you have more complex requirements, then the intention is that you will use some external policy agent, okay? And so there is already a library of rules in Rego for OPA, which are based on the existing pod security policies, okay? Very common use case are enforcing use of labels, just seen an example. We could do something like preventing use of a load balancer service, or at least by some users or in some namespaces because of the cost of a load balancer in a managed cloud environment. And then various other best practices. Okay, so like enforcing requests and limits on our pod spec, for example.
Yeah, the good citizenship of Kubernetes.
Yeah. And then some other more sort of random examples. Terraform, maybe if you're doing an AWS EC2 config with Terraform, you might want to check what regions are being used, limit those, check that that should be security groups, not security policies. Mixing my metaphors there. That the security groups are compliant to whatever rules you make. So that might be the particular ports you open, particular protocols you enable, or the particular side ranges that you enable them on. Okay. Another one could be to make sure you're using SSH key enabled logins in your Terraform config, and so on. Okay. Similarly, for some SQL, could be applying role-based access controls on top of that. We can even do like authorization around SSH on the OPA website. As an example, I think it's integrated with LDAP or PAM, I don't remember which, for limiting SSH and sudo. Okay, and yeah, this is just more examples of Kubernetes policies. There was a blog post from Styra about the top, most common, most popular cases. So a common one is basically around your images, okay? Either specifically, are you using a trusted repository? You might provide a list of allowed repositories, or more specifically, it might be things like not allowing use of the latest tag, or I coded a perversion yesterday, forcing that you use a semver tag, for example, so a major.minor.patch version for images. And so on. I won't go through this whole list. There is also actually quite an extensive library of probably 30 to 100 existing rules for Kubernetes policies in the OPA Gatekeeper project, which I'll talk about later. Okay, so we've seen some example policies already. Let's look just in a little bit more detail at one of those. You may be aware that there is a recommendation in the Kubernetes documentation to enforce these 6 labels that we see here. Frankly, I find them a bit overkill. At least I don't like the length of them and so on. Personally, I'd go for just something like an owner, maybe a team, something like this. But anyway, this is what's proposed, and so we can have rules that will enforce those labels. Okay, so here we actually have a policy. So this enforce labels, this is part of the policy. Okay. So we're setting, actually that is a set of labels. The curly braces means that it's a set data type. And then similarly here we have a list of operations. So these are the operations as we receive them as a Kubernetes request. Okay, so kubectl create will obviously produce a create, but kubectl apply or a patch, I guess, would produce an update operation. Okay, so again, we have a deny rule. Okay. And again, the way this works is that we evaluate all these rules. The first one, which is false, and we leave this rule, okay? In which case, we don't deny, okay? If we have a group of deny clauses, this is just one, then we would then go to the following one, and basically it's an OR operation between the different deny rules. But within a deny clause, then we're ANDing the different operations to get through to this last message. If we get through to here, then we will deny the request. So in this one, we can pick up all the parameters of the request JSON via this input.request variable. And then we can get the kind of the deployment. Don't ask me why it's kind.kind. There must be some good reason, but this is related to the way the admission control sends us the information. And so in this case, we're saying, okay, we'll apply this rule only to deployments. Now, actually, you would want to do that for pods as well, if you do, and in fact, for any other types of controller. But it's just one example. Okay, so this rule only for deployments. And here we basically check that the input request operation, okay, so the operation field that comes in the JSON request corresponds to either create or update. Okay, obviously we don't care if we're doing a GET request. It's only if we're creating or modifying a resource. Then we get into some more specific logic. It's a bit hairy, I'm afraid. So here we're producing a set. This provided value is a set, which we're creating from this, what I call a set comprehension. Basically, we're looking at the request object. So this is a create or an update request to create a deployment, and we're looking at the labels field within that create. Okay, and this means we're actually pulling out every label that has been provided. Okay, so all this logic here is just filling in this provided field as a set of all the labels. Similarly, then we're going to set the required variable again as a set by taking all the values in this enforce labels. Okay, actually, it occurs to me this is an old example, and I don't know why we don't just use enforce labels directly here, because this is already a set. Probably would work. Okay. The next thing we have is we create a missing variable. Now this will be of type set as well, and we're doing basically the set difference between required and provided. So basically, we're saying if there are some required labels that aren't in the set of provided labels, then those are missing labels. Okay, and in that case, then the count of missing will be greater than 0. In that case, we fall down to the last rule, and we deny the request, saying that this set of labels is missing from the request. Okay, so that's an example Rego policy. One nice thing about the playground, let me just show you that very quickly, is here we can actually save away our experiments on the playground. Oh yeah, okay, so I'm having I need to get out of full screen. I'm terrible. How do I get out of full screen? Well, Brenda will be able to edit this part. Okay. Okay, thanks, Pascal. Okay, so let me drag this across. So I don't want to spend time on that, but just to show you that I actually clicked on that link in the slide, and this took us to, this is actually some Rego that I'd created 2 years ago. In fact, you can even see, I was never noticed, you can see the creation stamp there, October 2019. So it's really nice to see that link persists, and I can now go in and actually evaluate that rule. We can see that in this case, because we have, in fact, I've limited just to this single label, which isn't present, and so our request got refused. And if I want to add that, we should, oops, should be able to get that working again, assuming I don't have any copy-paste issues. Okay, do that evaluation again. And this time it was okay. Okay, you'll see that took 10 microseconds.
Most probably, yeah, because if you look here at the admission review, for example, you can find here the kind, that 2 times kind in the JSON. Yeah, exactly. Yeah, it's that's the way that admission controller sends us the information. Yeah. And then just one thing. Notice this publish button here. So if I wanted now to share that, I click on that, and I have a new permalink that I can copy here. Okay, and they even show you how to run this scenario from the command line with the OPA command line tool. So quite nice tooling. Okay, how am I doing for time? Probably terribly. Oh no, not as terrible as I thought, so that's good. Okay, I'll skip over those. And okay, so let's just look a little bit at the command line tooling, because we love the command line, don't we? Okay, so just know that, yeah, we can build up test rules, as we can see here, for example. Actually, this isn't a test rule, this is test data. And then I have a test rule here. And then we can run those against our policy to test out our policy. Okay, so I'll do that in a moment. Let's just look, or maybe no, I'll go to the command line straight away. It's a bit more complex, but okay, where are we? Let me just show you actually very quickly, going off piste already, the conf test tool.
So if I have a set of YAML files here, for example, and I have a policy directory with some Rego rules that I want to enforce. So here, for example, some Rego to, again, checking on labels. Okay, here's another one, enforcing security context that we must not run containers as root. That's a bit more interesting, that one. And the other one on images, checking that the image is tagged, checking that it's coming from a trusted registry. And with conftest, I could take just conftest test and then one of those deployment files. If I take the first one, we see that it fails 4 of those rules. And then I have a second file already prepared. And that's not what I was expecting, actually. Okay, so in fact, I didn't have a label app. So this will fix this rule. The deploy.1 had this not app label, and in the deploy2, I changed it to app. So if I run that conf test again on deploy2, we'll see now we're going to get 3 errors, and so on. Okay, I won't spend time on that. And similarly for Terraform, I have an example Terraform configuration. Okay, and again in the policy subdirectory, I have some rules. Deny Rego, so I can do some testing on the load balancer. Is it using HTTPS? On the CIDR blocks used on any ingress security groups. And also whether I'm using encryption on an Azure managed disk. Okay. But okay, that was just a taste of that. I will go back to straight OPA, which is here. Okay. So I will only, I think, just show one of these examples. I don't want to spend too long on this. So thankfully, this isn't yet another rule on labels. This time, I did a set of rules based on the images, container images used in Kubernetes. Okay, so this first rule, what I do, I check that the request is coming from a trusted registry. And up here, I should code this really to allow multiple repositories, registries. I've set one just to localhost :5001. Okay. And I have a unit test file. So in fact, we can define Rego files as unit test files if they just finish with _test.rego. Okay, so this now is a unit test file. As you can see, quite a few things here. So the first one is some data with just some sample images, okay? And you can see that I'm calling this input container allowed because these both start with our allowed, in fact, registry, localhost 5001, okay? And then I have some bad images, okay? So I have one not localhost 5001, I have malware.io and docker.io, so none of those correspond to my policy. Down at the bottom here, I have something that will actually build up a partial Kubernetes request to create a pod, okay? It's not the full thing, but it's sufficient for our testing. And basically, we will call this function with one of these lists of container definitions, okay, to build up the full request. Okay, so now let's look at the 2 rules. So I have a rule which should pass, okay, this should only be allowed containers. So I'm building up my input using this input review function by passing in, well, this one, the input container denied, these 3 bad images, And on the first one, the allowed container, I'm passing in the input container allowed list. Okay. And in the first case, I'm counting the results. As these are all allowed, okay, I should not get any deny on these. Okay. So so the count here should be 0, and we're fine. Okay. On this one, though, with the denied container, they should all fail. So the deny actually should produce 3 results there. Okay. So if I now run OPA, OPA test, my source rego file and the source test rego file, it will do these 4 rules. 2 rules, the input allowed and input denied, and it tells us I have 2 passes. Okay, now that's not very interesting on its own. You can use the verbose option. Obviously, normally when things pass, you don't show the details. With the -v option, we can actually see the individual rules and also the actual time that it took to evaluate the rules. We can also, I'm not used to using the option, there's a bench option, which I've used. If I've used it in the right way, I guess we'll be looping around those tests. Okay. And so we just get a clearer idea, yeah, the number of requests it was able to do per second and so on. Okay. And I do have some more complete examples. Okay, so this one, I extended that policy, so I still have my first deny rule checking that I'm using a trusted registry. And then I've added a new rule where I do a regular expression match on the container image to make sure it has a field colon and then number dot number dot number. Okay, and basically I have to satisfy all my container images must satisfy this regular expression, and if they don't, well, I have a not all satisfied. Then we drop through to the last rule, and we would report which images don't satisfy the semver condition. Okay. And then in the test file, I just have more examples. Okay. So I have some good examples with some valid semver values, maybe not valid for Nginx, but they're valid semver values. And then I have some bad ones. So here I have a rule. Let me cover these 3 first. We can see that none of these have a semver label. One of them has latest, not good. One of them doesn't have a tag at all, so latest will be assumed, not good either. One of them is 1.2, which isn't full semver. Okay. And then up here, I have 2 more rules. So one of them, yeah, in fact, both of these, okay, this one will be rejected because it's using the registry docker.io, even though the semver is good. And this one will actually be denied twice because it's using the wrong repo, registry rather, and because it doesn't have a valid semver value. The reason I mentioned that is because I was actually having trouble debugging this before I realized that, yes, this count here, in this case, the denied request needs to be 6. I have 5 examples of container images that should be denied, but one of them here will be denied twice. Okay. So I won't go through the other examples on that. I want to get to some more interesting examples. Let me just see. Oh yeah. Very briefly, I showed you the 3rd example where basically, so I basically had those same rules still for pods, okay? And then I create equivalent rules for controllers, okay? So deployment, daemon set, stateful set, job and cron job. Actually, I think there is a bug in this rule. I don't think this will work for the job and cron job because I don't think they have the same template spec. Anyway, the real difference here, anyway, is of course we now check that the kind is one of this set of controller kinds, and instead of using to get to the image, instead of using input review objects spec containers, we have to go deeper to spec template spec containers. Okay, thanks, Pascal. So, okay, yeah, I thought there was a difference. Yeah, so it's template, but it's job spec for the cron job. Okay. So my unit test. I don't have sufficient data to fully test it. It would bomb out on the cron job on this part. Okay. Okay. So that's examples of doing unit testing, and then the slide is just a simpler example. Okay. I've done that demo. And see how we're doing time-wise. Huh. I'm a minute ahead of schedule. Well, I can breathe. Okay, let's. Okay, maybe I did go a bit too quickly with the demo. Any questions on that, by the way, Pascal?
No questions from my side. Everything is clear, Michael. Thank you.
Okay. Okay, cool. I'm actually very glad to be on schedule. It's bonus. Okay, I will nevertheless go through this section rather quickly. I mean, really, I just wanted to make the point about what admission control is all about with Kubernetes. Okay, so first look at Kubernetes admission control, how that is handled, and then specifically how OPA works with Kubernetes. Okay. Okay, so I love to say that Kubernetes is pathologically extensible, and this is one of the reasons why policy engines are of interest. You know, Kubernetes. Well, Kubernetes first of all is a very dynamic project. It is advancing very quickly from one release to another, and your deployment of it as well. There are so many options, ways you can extend Kubernetes that really makes sense to have a pluggable policy agent to be able to develop your testing independently of the platform. Okay, so let's look very briefly at basically API, Kubernetes API access control. So of course, any change that we want to make to the platform, basically that corresponds to a change in the desired state, that will all pass via the API, whether that's coming from something outside the platform, me typing kubectl create deploy something or other, for example, or within the platform, something making an API request to create some resource. All those requests will pass via the API. And there are these three important stages. The first one is authentication, determining that you are who you say you are, what does that mean? It means that typically, like doing kubectl, get, create, whatever, we will pass some sort of token through the API that identifies as a particular user. The next stage is authorization, where we can have RBAC controls. There is an older form, ABAC, attribute-based access control. I believe it's still available, but generally speaking, RBAC is used for authorization. Now we know who you are. We're checking basically, do you have the permissions to do what you're asking to do? Okay. And not only can we use RBAC or even ABAC if we really want to, we can also have a webhook to call out to some external engine to help us out there. And then the final step is still verifying if your request is allowed, if it's valid. So this could be applying policies. So the policy could actually still be doing some role-based access control, but maybe with some finer grain details than RBAC allows you to do. Or some other types of policy like checking labels, checking that we're referring to allowed images, allowed image repositories and registries, and so on. And we can do that. Well, there are built-in admission controllers within the API server. I do have a list of them in a moment. And then there are external ones we can call through webhooks. And that's what's really interesting to us here. And the important thing to know, of course, is that if you get through all of these stages, then your request actually gets written into the etc.d key value store. Okay, if you're doing a create or a kubectl run or something, you might imagine that the request gets sent through the scheduler. No, it gets written through to the key value store etc.d because that represents our desired state for the cluster. Okay, of course, the scheduler will then be notified by a watch notification and the change will then be affected. Okay, so we can have webhooks at each of those stages. I do have a doubt actually about the authentication one. But what is of interest to us anyway is the admission controller. There are actually several steps here. So the admission controller stage, if you like, actually has several admission controllers. We'll see a list of them in a moment. They are run first. In fact, I'll look at the list. Here we are. So I still had POS security policy, PSP, on that slide, but they are actually now deprecated, but we can still use them for the next 15 months or so. They're not yet removed. And then there are other specific built-in admission controllers that we have to enable in a platform for them to be used. Okay. What's of most interest to us is these two, the validating and mutating admission webhook, which will allow us to call out to an external policy engine. Okay, I'll just go back here. So that external policy engine, it could just be some code. Okay, we might have written, it could be in any language because this is just over an HTTPS interface. So it could be some Go or some Python, as long as it can receive some JSON and send back a JSON response, basically saying, allow or deny, then that can be done. But the disadvantage is that generally that would then be with hard-coded rules within your code. Obviously, the advantage of the policy engine is that the rules are in a specific policy language, okay, and that they can also be updated dynamically. Okay, so in this chain, the built-in admission controls are applied first. Then we'll call the optional mutating webhook. So this would allow, we could call out to our policy engine, and we could, for example, the enforced labels rule, we could say, okay, you haven't put, let's say, this app kubernetes.io name label, so we'll put one on for you. Okay, it's not going to be very useful. It's going to be, the value will not be that meaningful, but we'll nevertheless enforce that policy. Okay, so we can do that. We can modify the incoming request. The next stage, represented by this asterisk here, would be doing schema validation. Okay, so you might have just modified the incoming request. That's a suitable moment to actually do schema validation on that. Is this a valid Kubernetes API request schema? Okay. If that's okay, Then we have the possibility to have the optional validating webhook, where this time we'll have rules and we'll say basically allow or deny the incoming request. And so that is where we would invoke OPA, for example. Okay. So one thing I think is a little bit confusing with OPA is that we've seen already the OPA command line tool, and OPA itself is really, I would say, embodied by that command line tool or the library that uses. Okay, that is the functionality of Open Policy Agent. Then integrating into Kubernetes effectively, we actually use it with a gatekeeper. Okay, now the first iteration of this was probably not actually called Gatekeeper initially. Okay, and often you will see references to this without explicitly saying that it is the Gatekeeper version 1, or not very clearly. And even the openpolicyagent.org website actually refers largely to this Gatekeeper version 1. Nevertheless, what you would tend to want to use in production these days generally would be the Gatekeeper version 3, which we will actually be using. Okay, but I will talk about both. I won't say anything about the Gatekeeper version 2. It was an improved version of version 1. It was better, but given that it's already been superseded by version 3, it's not much sense to talk about that. Okay, but let's look at the version 1 briefly. So version 1, the idea is that you would run the OPA policy engine in a pod with a sidecar. Okay, so before I talk about the sidecar kube management, we can see here, as I said earlier, that typically you would have some sort of gateway managing API requests, allowing them through or not, but calling out to our policy engine using its rules, deciding whether this gateway or admission controller should let the request through. Okay, that's the basic model. And particularly in the integration with Kubernetes in the first version, so we have this kube management sidecar, and its job is to actually do caching of resource data. So remember, our request might be creating a pod or creating a deployment, but maybe for the rules to be effective, we need to know about other pods in the system, or namespaces, or ingress rules, or whatever. Okay, so there is other resource information that we don't obviously we don't have them in the request. Okay, so what we can do is we can define particular types of resources and maybe namespaces from which we want to periodically pull in information and cache them as an inventory, and then we can reference them in our Rego policy rules. Okay, that was the version 1. Worked quite well, but we'll see in a moment that the version 3 is quite a bit more extensive. We're at 8 o'clock. How about we take a 5 or 10 minute break before I move on to the real meat, Pascal?
That would be a great idea. Let's get some coffee.
Okay, 5 or 10 minutes, you tell me.
Let's do 10 minutes.
Yeah.
You're talking for a long time, so I know you need to rest.
Yeah, thanks. Okay. I'll just rule the timer. Okay, see you in 10. Pause recording. Okay, so just to recap a bit, I mean, we've looked at pure OPA, seen how it's a useful command line tool for applying our policies and even unit testing our policies. We've seen how there's the Rego playground online. You see already there's a lot of flexibility around OPA, again, with the ability to include it as a library, load WASM, for example. Pretty flexible. And I've shown you as well the what we call the version 1 gatekeeper, which might seem a bit strange, but it's still quite present on the Open Policy Agent website. That's why I include it there. Nevertheless, going forward, generally, you would want to use this version 3 that we're going to look at now. Just note the time. So let's get going on that. So this is the basic idea of the version 3. Obviously all centered around OPA running within our cluster as with the version 1, but this time we have some more semantic in there. We have some CRDs that we use to actually describe the constraints, actual policy rules, and we have templating of those so that we can reuse existing templates with extra parameters, which is quite nice to have. Okay, so you can see in the middle there, watch tree sources. We still have that same capability of syncing resources of the platform. We don't want to just pull in all resources, but the ones that are relevant to our rules, okay, to our policies. So as in the version 1, obviously there's the webhook admission controller, which is going to send us the actual JSON corresponding to the request. So we call that message the admission review here. Okay, and so we receive the JSON that corresponds to the request being made. But this time the rules, rather than being pure Rego files, actually, I didn't mention in version 1, they're not pure Rego files either with Kubernetes. They're actually stored in config maps. This time we have the specific constraint templates, which are CRDs, and we define a new constraint type, which we then instantiate. Okay. So we have the watch tree sources, just like in version 1. We have a different way of defining the policies, so the constraints, we'd say. And one other small difference is we also we write out audit results to the constraint resources. Okay, so you can see what's happening to our policies. That's the overall architecture. Otherwise, yeah, how does this compare with version 1? Well, version 3 produces quite an extensive library of policies, which are parameterized, meaning, for example, we could have a template constraint which says a particular label must be present or must be present with a particular value, and the actual key and value can be passed into that template as a parameter. Okay, so we can reuse that. So we have these well, constraint templates should be up above constraints, and then we have the audit functionality. So we'll see that there's a field that we can set the enforcement policy to either deny or to dry run, giving us the audit functionality. Skip over this, just installing Gatekeeper. It's quite easy, basically. Of course, when you say it's quite easy, this doesn't say much about the robustness of the solution. So let me just say 2 words about that. Obviously, this is being deployed in your cluster as one or more pods, so as a deployment. So by default, it is essentially highly available within your cluster. But bear in mind, this could be affecting all requests coming into your cluster. So you really don't want this thing going down. So you really will want to pay special attention to the high availability of your gatekeeper. Okay, so what that means is having sufficient replicas across the nodes of a system. If you have quite a heterogeneous system, maybe across multiple regions, making sure that you set constraints to be sure there's a good topology spread across your cluster. Okay, so there are things to do just to make sure that you have good redundancy on the gatekeeper. Okay, 10-minute break, we've done that. In a moment, what I'll do is I'll look at some of the provided demos for the gatekeeper. Okay, there's one called Demo Basic and Demo Agile Bank. There are some others that I intend to develop. I haven't done those yet, I'm afraid. But those examples are pretty good, though it does seem to me there might be one or two bugs in them. But the important thing is that we see the principle, we see the nature of the rules we can do, and so on. Okay, so the first one, Demo Basic, is all about making sure a particular label key is present, and then also the second step, making sure that you have a unique label value. The first thing here is we have a config entry, and this is what we can use with the gatekeeper to determine what data we want to have synchronized into our data inventory. Okay, so remember, this is asynchronous recuperation of information about other resources in the platform that aren't related to our request, but become related by our policy. Okay, so if we want all namespaces to have a unique label value, then obviously we need to know about other namespaces, and so we want to sync information about all the namespaces across the cluster. And the pod, probably for a later part of the demo, but we need information about pods as well. Okay, so let's look at how we can enforce these policies. So basically, we'll be using the constraint template to create a CRD called K8s required labels. Okay, and then we will instantiate that with one particular instance to say that we must have a gatekeeper flag. That's the gatekeeper key, I should say. That's the first step of the demo. Okay, so this is what the constraint template looks like. So I've split it into two parts. On the right hand, this is the actual, this is the actual Rego code, okay, which actually appears on the left at the bottom of the page. You can see there the Rego colon and the pipe, okay. So this constraint template will be defining a custom resource definition, okay. The kind of that CRD is K8s required labels, and here we specify the parameters that can take, in fact. Okay, so properties, we have labels. Okay, so we can specify what are the required labels, of course. Once we've done that, then that is another element that is available to us within our policy rule. Okay, so if we look here, sorry there isn't more spacing, making that Rego a bit more readable. But we basically have one rule defining whether or not we have a violation of the rule. And we have two sources of data there. Okay, so we have the input review object. So this is what is coming. This is our incoming request, the admission review that we're being fed with. Okay, so that's the requested resource that we want to create. And then here we're referencing the input parameters. Okay, so these are the labels that have been defined in our instance of type K8s required labels. Okay, so when we run this policy, again, we'll be doing the same sort of things before. We'll be building up a list of the provided labels in the incoming request. I said a list, a set rather, and we'll be building up a set of the required labels that we've passed in as a parameter to our K8s required labels type. And then, as usual, we do a set difference operation to see if there are some missing labels in the required set, but not in the provided set. So of course, if the count is greater than 0, then we drop down to the last step and we provide the error message that you must provide labels. Okay. Okay. So that's the constraint template. And so we're creating this type K8s required labels. Now we can create instances of that CRD. So it's called K8s required labels. So we can create one. NS must have GK. So we're saying basically all namespaces created from now on must have the label key gatekeeper. Okay. We haven't provided a value, so any value is acceptable, but the key gatekeeper must be present. Okay. And then, of course, following that, if we create a namespace and we don't provide a gatekeeper key there, then we'll, of course, get an error back. Okay. I'll probably skip all these slides now, and I want to get to the demo. Okay, so I have more slides about the second step, where we check for a unique value on the label. Okay, we'll look at those in the actual code. Okay. Okay, let's go to the actual demo. Okay. So I'm going to cheat. Doesn't follow that link. Okay. So there is a scripted demo available in the Gatekeeper project repository. So I'm going to look at that. Just maximize that. And that will basically step us through the scenario we've just seen. Okay, so the first thing we're going to do is we're going to sync, going to apply that sync.yaml. And I think it will show us, no, it doesn't actually show us the value, but it's the same as I showed you before. It will be syncing all the namespace and the pod information from the cluster. Okay. Now we will create a namespace that doesn't have any special label, but we haven't applied any constraint yet. Okay. So that, of course, is created. Now we'll look at the template. Okay, so this is as my slide showed you, but now properly laid out. Okay. So our template just takes this one parameter, which is the labels array. And in the code, we check that we have the appropriate labels there. So that's the template. Create the template. Okay, and now let's look at how we can instantiate that. Again, it's as I showed you in my slides. So basically, we'll create an instance of this K8s required labels type we just created. And we'll say that namespaces must have the label key gatekeeper. Okay. Okay, and what I'm going to do is, just before I do that, So if I do kubectl get constraint templates, okay, we can see that K8s required labels has been generated. Okay. But at the moment, we don't have any instances of that, of course. Okay. Okay, so now we will apply this. And now we should see that we do have an instance of the K8s required labels. Okay, so let's have a look at that. Let's do a describe on it. Okay, so we can see that's been created, and we actually see it has already detected 10 violations. Okay, so it's looked at the existing namespaces and complained that they don't have this gatekeeper value. Okay, that doesn't actually, it says enforcement action deny, but it doesn't actually destroy those namespaces, thankfully. It would have been very nice for my demo to destroy the kube system namespace, for example. But it does show us some audit information there. Now, and up top, I just actually show you the timestamp on the audit as well. Okay. Now, something I was surprised about with this, I need to look into that. Excuse me. Okay, when I actually now create some bad namespaces, if I look over here, it doesn't add more violations. We don't actually, oh, sorry, and this was even created. Hold on, that's not right. Double check that. As I say, I did see some errors with this demo earlier. It's possible I just haven't got the latest version. Okay, but we can see that should have produced an error. That's embarrassing. So it doesn't have the gatekeeper label. Okay, well, I will continue on. I'm surprised we didn't get the error. I'm pretty sure I did get that earlier. Okay, and this one does have the gatekeeper values, of course, that will pass. Okay, and of course, that was created. Yeah, that is weird. I don't know why that first one didn't fire. Okay, that's annoying because that demo was working fine earlier. It's the actual second part of the demo that was failing. So see if I have a 0% failure rate. Am I consistent? Okay, so this one, now we're going to create a new kind. Okay. So again, from the constraint template, we're going to create this CRD K8s unique label. Let me just focus on that. And that also takes the properties a label type string, so not an array this time, just a label. And then we have our regular rules, and this gets a bit more involved in the logic. Okay, so we have a function here that will take our kind field and it will build up the API version, so the group and version from the group and version parameters there. And we have another one this first one, it takes group and version because we have the rule that the group is not an empty string representing the core API. Okay, so if we have something of a core API, we will build up app/v1 or something like this. And the second rule, it has the condition in the case where the kind group is an empty string. Okay, so this is the core API. In that case, our API version is represented just by the version, so v1 or something. Then we have this identical namespace. In fact, yeah, I would have named this differently. This is identifying identical namespaced objects. Okay, so we're actually passing in two objects, the obj, which you see in a moment, and the input review. Okay, and we'll actually see that it actually iterates over. For this one, it's actually this line, NS objs. So actually, we have a list comprehension here. We're stepping through all the namespaced objects in our inventory. That's what this represents. And then it's looking for objects that are not unique. Okay, it's detecting if our incoming object is not unique compared against these namespaced objects across the whole cluster. Okay, so that's what this identical namespace function is doing. So it's comparing for each object, basically each resource in the cluster, it's comparing its namespace with the request namespace. Same for the name, same for the kind, same for the API version. If all those things are equal, then it means that we're trying to create an object that has those same characteristics. Okay, that isn't necessarily a problem yet, but we'll use that later then for checking the labels. Okay, and then the other thing is we have this cluster obj, which is doing the same thing, but it's actually iterating across cluster scoped resources in the cluster. Okay, so things like nodes, namespaces, and cells are cluster wide. They're not associated with a namespace. Okay, and so for that one we have identical cluster. And in this case, we compare these parameters, but we don't compare the actual namespace because neither of them actually has a namespace field. Okay. Then we create a list of all those identically named objects, whether they're cluster-wide or namespace-wide. Okay, we do this array concatenation there. Then we create the set of all the values that they have. Okay. And then again, we do a set difference between, now this is, where this file comes from. We do this from the set of values of the incoming request and all the values from these non-unique resources across the cluster. Okay. Basically, if there's a difference there, then it means that we have a, sorry, if there's no difference, rather, comparing to 0, then it means that we have a duplicate label value. Okay, I hope I explained that logic. Okay, it's all a bit heavy, and frankly I do find the Rego logic quite difficult to interpret. There's definitely a steep learning curve there. Rego is very powerful, but it's definitely a language that you have to learn. Okay. Okay, so that is our template definition. We will now define that. Okay, so just go over here. If I look at constraint templates, we see we have a new one called KTS unique label. Of course, we don't have any instances of that yet. Okay, I don't know why that isn't auto-completing. Oh, one more. Okay. Well, the auto completion wasn't working. No problem. Okay. So we have our template, and now then we will create a new constraint. Okay, looking for unique values for the gatekeeper label. So we look at an example. So I've created that constraint now, and if we look at an example namespace here, so we'll create a namespace called no dupes. It has this label gatekeeper with the value not duplicated. Okay, of course, no other namespace has that for the moment. So when we actually create that, there should be no conflict there. And if I do a describe, we can see there are no violations there for the moment. Okay, now this demo was failing for me earlier. Let's see how we get on. Okay, so this one, what are we doing? So yeah, we're creating another namespace. Okay. Okay. Actually, no. Okay, that should. Okay, so we're creating another namespace with the same gatekeeper label, but it has the same not duplicated value. Okay, I think this is a problem in the logic here. It's possible that it's on the cluster one. I think we need to remove this line. Okay, so I think we're not identifying this as identical because they have the same. Sorry, they have different names for the namespace logically. Okay, anyway, let's run that. Okay, and you can see, well, it didn't fire, and we don't have a violation here, so there is a problem with that demo. Nevertheless, I hope you saw the principle. You can see that these Rego rules are really quite powerful. Okay, this is just showing you, actually this was the first one, just showing the violations on the label. Actually, there is a new violation there. Okay, there's the bad NS up there. So yeah, it's something very strange because it's saying it's violation, enforcement deny, and it was a new one, but the namespace did get created. Let me just double check that. Yeah, bad namespace, bad NS. So, okay. I'd like to say it's the demo effect, but I can tell you that I've seen that error previously. So, okay, clean that up. There's a second demo, which also half works. The second half of that seemed to have an error earlier. Hopefully this time at least the first half will be fine. So again, this is there's a link to this in the slide. This is in the policy gatekeeper GitHub repo. Okay, so you can run these yourselves. Again, cowardly, I will run the demo.sh. Okay, so here they create a bit more of a user story. Okay, developer, he creates a namespace, presumably does lots of stuff in it, and then 5 weeks later he actually moves on to another project, and of course the namespace has been forgotten, because these days you don't just get VM sprawl, you get namespace sprawl or general resource sprawl. Okay, but our admin, he's hot on the job, and he's noticed we have this advanced transaction system namespace, so he's wondering, well, do we use it? So he spends 3 days trying to figure out what the heck this thing is someone actually using it, and he discovers that the project has been scrapped, and so those resources should all have been scrapped in that namespace. Okay, so he says, I want to be quick there, never again. So he starts looking at doing policies on his cluster. Okay, so he creates a set of templates. Now we can actually look at these. Let me do that first before. Templates there, so look at them. So first one, allowed repos template. Okay, so we can expect imagine the sort of thing that's doing. So this is actually checking the image repository value. Okay, strictly speaking, they're actually just checking what the container image starts with. So potentially it's the registry, even the full image name, in fact. But they're checking that at least that container image starts with whatever parameters we passed in. Okay. And so we would just looking. How would we pass that in? So okay. Okay, I didn't notice yet. We have a repos array parameter. Okay, and so we can pass in a list of repos. Okay, now those repos could actually be like registry / repo name, strictly speaking. And so why do we have two rules? Okay, yeah. The first rule is so checking on the pod spec containers field and then looking for the container image within that. And the second rule, exactly the same, except it's picking up the init containers field. I guess strictly speaking, you could do also ephemeral containers now. It all adds more and more rules. But that's what you should be doing. Okay, and this, well, implicitly, I guess, is acting on pods, okay, rather than on workload controllers. We'd have to create an extended rule for that. Okay, what else do we have? Let me see. Container limits, that's a good one to have. Okay, so making sure that we have CPU memory request limits in our pod spec, in the container definitions of our pod spec. Okay, that's quite a long one, so I won't go into the detail of that. Okay, you can see quite an extensive example there. Okay, I won't go through all of them. We'll come across some of those in the demo. So apply those templates. And now we'll create a set of constraints based on those. And okay, it's going to actually show us this time, at least one of them. So first constraint, yeah, owner must be provided. So presumably this is a label test. So presumably, I see there's a K-test required labels template we've created. So this presumably be one of those. There you go, K-test required labels. And we're saying that all namespaces must have an owner. Okay, so this is obviously going on from our user story where we have the developer who moved on and left this namespace hanging around. One interesting thing here is in the constraint parameters, we're actually setting we're doing some regex matching on the owner field. Okay, so basically we can have any alphabetic character, not alphanumeric, but alphabetic, followed by .agilebank.demo. Okay, up to the end of the name. Okay, so that's quite a nice rule to have. So from now on, we'll know who our namespaces belong to. Okay, so we've created all those different constraints. And now so developer comes along, another developer wants to create a production namespace, and of course this fails. and it's actually failing on the must have an owner. Okay, so he says, okay, I'll be a good citizen. I'll put an owner label on my namespace now. Actually, a bit of a bad example. so actually, I think you have a good sense of humor. So he's now corresponding to the rule. He has some alphabetic characters .agilebank.demo is his owner, but unfortunately it's me, and our policy doesn't protect against that. Okay, so we're going to create that namespace, and of course that gets created if we don't have a problem with the policy this time. So on he goes, and this time he's going to create something with no limits. I don't remember what resource type that is. Okay, and of course this is bombing out. So let me actually have a look. What are we creating? Good resources. Namespace.yaml. Hold on, no, sorry. I should be looking at bad resources. Oh, yeah. OPA, no limits. YAML, and so what is it? We're doing a pod directly. Okay. A pod, and of course, as you can see, it has no requests or limits, no CPU memory values there. Okay. And so we can see actually this is complaining about more than just that. So we have this container must have limits rule, which is firing. Okay, we have no resource limits. And also we have a rule on probes. Probes must be provided. Okay, and so it's also complaining that we have no readiness or liveness probes in there. As you can see, we don't have any of those. Anything else? Looks to be the same. I don't see the difference there. Resource limits still. Okay, those seem to be the same errors. Okay. So on he goes. Okay, so now he's going to correct that, at least partially. He's going to put those values. What's it called? It OPA limits too high. Okay, so this time we've put CPU and memory limits there. We can see, so CPU is okay, but we've put 4 gigabytes of memory, which presumably goes over some limit that was specified in our constraint. So there we go, and it's telling us both the CPU limit, and the memory limit. So CPU limit is going over the limit of 200 milli CPUs, and the memory limit, 4,000 megabytes, is going over the 1 gigabyte limit that is set. And we still don't have the liveness and readiness probes. So what's he do next? Okay, so poor guy is still not there. He looks like he corrects some or most of those problems. Let's look what he does. Okay, so he's reduced his CPU and memory limits. He still hasn't put liveness or readiness probes there. And he's using, well, presumably this repo goes against the constraint we have. Let's go and do that now. So we still have the must-have probes. We don't have the problems with our limits anymore. And I'm looking for it. Okay, invalid image repo. Okay, so gcr.io is not allowed. And if we look at the actual policy, what was it? Repo, so allowed repos, okay. Okay, okay, that's the template. Sorry, so if I need to look at the constraints, and we had production repo. What did we say? We say that we only allow the open policy agent repo. Okay, so that through. In fact, okay, that was actually written here in the error message. I didn't notice that. Okay. And finally, presumably he's done good this time. Yep, his pod finally got created. Let's actually have a look at the final good solution there. Okay, so this time he has everything. He has readiness and liveness probe. His container image is using the open policy agent repo. And we also have resource limits within the appropriate range. Okay. Yeah. Okay. And I think this one didn't work for me earlier. Saying duplicate service. I don't see why, because I don't think services across the whole cluster. No, we don't have a gatekeeper test service, so this will, if we apply this, this will not fail. So again, another bug in the demo, I'm afraid. Okay. So he's supposed to have had an error there, but of course he didn't. Okay. So after a while, yeah, they have a resource problem. Okay. And it's because they realize, yeah, the resources in the cluster that don't have any resource limits. Although we've enforced them now as a policy, presumably there were some existing resources already created that didn't have any limits and have basically had some memory leak over time. Okay, so we can look at the audit results and see what pods, what containers don't have any limit constraints. Let's do that. Okay, so we look at that container must have limits constraint, which we created. And we'll actually look at the violations, basically. And we can see, go up there, there are actually 33 violations across the cluster. Okay, now this isn't actually their same scenario, and they don't actually clean up my cluster. That's actually the, not quite the end of the demo. But anyway, they fixed that problem anyway, manually. Oh, yes. Okay, so you have another demo on ingress host names. I think I'm going to skip this. I don't remember if that particular part did work, but again, I mean, it's more iterations really on the same thing of looking at the current resources on the system, in this case, ingress rules, drilling down to get out the host names that are used in the rules, and then comparing to an incoming request to create an ingress rule to see if the host names are unique or not. Okay. What I would like to just mention, at least, just put a link here to the Gatekeeper Library. Okay, the Gatekeeper Library look at that just to see that there really are quite a lot of policies there. Tree will show us a lot of stuff. Probably about 150 separate YAML files, something like that. Okay. And so let's look at some examples all the same. What they provided. So we look at, let's say, the general. Oh, what's nice to see is they provided a library of stuff for the pod security policy. Okay, obviously today you can still use the inbuilt pod security policy, although it's deprecated. In the future, we'll have to re-implement that ourselves. Okay, and so we can see a lot of the PSB there. So I don't know, if I look at one on users, for example, the template there, oh, it's quite a long one. Okay, that's a bit more involved than I'd wanted, but you can see basically they're checking for policies run as user, run as group, and so on. The sorts of rules that we had in pod security policies. Okay. What else do we have? Let's just look in the general section. So these will be sort of the stable ones, if you like. Obviously, you have required labels, required probes, unique ingress hosts, the ones you've seen in the demo. Image digests, so another variation on the theme, this time enforcing that you use a SHA-256 value on the container image values, okay, to be exactly sure of what you're putting in. Okay. Another one there, I see block node port services. So yeah, it's the sort of thing you might want to do. Block node port because you don't want to expose nodes of your cluster. It might be a bit more nuanced than that. Let's have a look. That's a fairly simple one, in fact. They're just blocking use of node port at all. But, you know, why not? Another one you might do, don't see it here, is you might want to block creation of load balancer service for some namespaces, for example, because that can be costly. Okay, just wanted to show that those exist. I will run back to slides now. That's all I have as a demo. Any questions on that before I move on and terminate shortly?
No questions about it.
Okay, let me skip the slides. It's all basically related to the demo we've been through. I have some other slides, just on some other use cases. What I've shown so far in terms of Kubernetes is all about intercepting the Kubernetes API, okay, as part of the admission control. Of course, we could use it for intercepting our actual application API traffic as well. And one way we could do that is by having some sort of gateway intercepting that traffic. So a good way of doing that would be to have a sidecar container in our application pods. One way of doing that would be through service mesh like Istio, or I think SoloIO's glue mesh allows this as well. Yeah, I'm pretty sure they do. Or we could just have our own sidecar proxy, okay? And that would either be linked to the OPA library, so loading regular rules, or as in the case of Envoy. So Envoy is a C++ library, so it wouldn't have easy access to the OPA Go library. I mean, it must be possible to do those bindings. But Envoy proxy has one other really nice feature, is that it has a WASM runtime, or it can have at least. And so Styra added to OPA the capability of building Rego rules. We actually can build a bundle of Rego rules that we can make available from a server. And one of the options on that build is we can do it to a WASM target, because that's really powerful. That means in your cluster, if you're using an Istio service mesh, for example, you could dynamically load new policies into your service mesh, and then you get those policies for free across your cluster, at least where the service mesh sidecars are implemented. Okay. Okay, actually, what I've just described, sorry, I didn't realize, I've just described this slide going via WASM. There is another option, which is what the previous slide was showing, was actually a more standard way of the gateway, so an envoy proxy actually calling out to OPA, and then OPA doing the policies. So in this case, OPA would be part of the dynamic environment. So you would pay some latency going over the network to OPA. In this way, this would actually be the faster way. Offline, we would have used OPA to build the rules into WASM, and they would then be dynamically loaded into the envoy proxy, and then the actual handling of the rules, the applying of the policies would all be done within the envoy proxy. So it would be much faster to apply the policies. And let me just underline there, I've mentioned latency several times. Seen that the Rego Playground talks about latency. There they are concerned with the time it takes for the Rego queries, and it's important. We've seen some very low values. We've seen like maybe 20 to 100 microseconds, which is very small. But as your Rego rules get more complex, as you have more rules within the same policy and multiple policies, then obviously there's a possibility that it will take more time to analyze those. But more importantly, if you're calling out the envoy proxy, sorry, to the OPA policy engine over an HTTP connection, then you'll be paying a latency tax for that as well. And if you're in a microservices environment, then that could be multiplied by the number of components of your microservice that you have. Okay, so latency is definitely important, and that actually, this wasn't on purpose. That's a good lead in to just talking about Styra's DAS product. I've not actually played with the product myself. Looks pretty nice. They provide you a nice dashboard for managing different environments. Obviously here they're showing 3 Kubernetes clusters, but that could be, your whole IT stack. Your databases, your servers, Docker even directly or whatever. And we can get a real-time view of the rules that are firing across your system. So that the level of charge, and down there at the bottom, that spiky graph is showing the actual latency. I don't see the units. It looks like it must be milliseconds, I guess. Okay. And I would say that one of the really important things for Styra with DAS as well is to get the best latency values from these policies. Okay, so I think having the nice dashboard, being able to manage different systems all in one space, and also optimizing latency and maybe the high availability of the policy engine. These are probably the value add that you'll get from the DAS product. On this slide, actually, we can see a bit more detail. So we can see, it's all very small, I'm afraid. We can see Kubernetes clusters. Actually, let me go full screen. I don't even know how to do that on the Mac. Okay, so we have Kubernetes clusters. We can see we have other types of resource. So we have a thing there, it's written Buffalo microservices. So yeah, Kubernetes clusters is more about the API, but here the microservices presumably is actually your microservice applications running in that cluster. And there we also have a demo envoy stack. Okay. Otherwise, you have nothing to sell, okay, but just information there about the DAS product. So there is a free tier. I haven't used it yet. I did actually sign up for it, but you can already play with DAS. Okay, limited to 20 enforceable rules. Okay, that's not too much. But they say you can manage OPA for 2 total systems. So I guess, for example, that means 2 Kubernetes clusters, which is not bad. Okay, and you also get a policy pack of security policies with that. Okay, move on. Okay, yes, just mention one thing. So the pod security policies I mentioned already, that has been deprecated already since May, the 1.21 release. Like all things that get deprecated in Kubernetes, there is a time during which it will remain in the system. So we have until, I guess, the end of the 1.24 release that will still be present, and it will be round about August 2022 that will be actually removed. So at that time, there will be other policies, other admission controllers implemented in Ambition Controller in the API server as today, but they will be simpler than the current PSP. And so if you want to go farther, you'll have to use some other external policy engine. So this session has been looking at OPA, Open Policy Agent. Another one is Kyverno. So I purposely haven't compared with Kyverno. I really would like to present on Kyverno another time, but in just a few words, Kyverno is Kubernetes specific, as you might expect from the K, rather than OPA, which can apply to your whole IT stack. On the other hand, and the difference is it's pure YAML that it uses for doing the policy rules. Okay, so that can be an advantage, a disadvantage. I'd say you don't have the same flexibility of the Rego language. On the other hand, maybe the rules are a bit simpler, and it does have some other capabilities that OPA doesn't have. In particular, in the same way, if you know the customize tool is capable of extending the cluster, sorry, extending resources by adding YAML blocks within an existing resource. In the same way, Kyverno can actually have generation of blocks or new resources as well. So, for example, we could create a deployment, and of course the pods would be created, but maybe we would also create some other related deployment. Kyverno would be capable of doing rules of that type. Okay, there's also some others, K-Rail, Magic Tape. I think there's another one that I forgot on there. Okay, oh, there we go. There's, oh yeah, this one. Okay, commercial products, of course, there's Styra DAS, and there's this one, CAP. I only learned about that today, actually. Okay, also, if you want to learn more, there's some links there from Styra, their blog, the Rego Playground, the Styra Academy. Okay, relatively simple, but will give you a good grounding in doing rules in Rego. So I definitely recommend looking at that, and also the Policy Agent Gatekeeper Library. I will skip over this. It's half my intention, actually. A blog post about different ways of implementing OPA in your cluster. the API gateway. Disadvantage here is that you're only influencing north-south traffic. Once you're in, then you're not protecting against further violations. Okay, you can't apply policy within the cluster. Another way would be doing explicitly particular resources within the cluster. We get a bit more complicated doing it case by case. Another way would be to be enforcing it everywhere, where you might have some service mesh type sidecar mechanism. And then there are a couple of experimental ways proposed by Anders Eknet, who wrote this blog post. I won't go further into those. They are unproven. I don't want to spend time on that. That's the only reason I won't go further on that. Okay, trying to keep this to roughly 2-hour video. Okay. So basically, we've seen how policy engines and OPA in particular allow you to dynamically provide policy rules dynamically, at least independently from the platform itself. We can update those in the running platform. We've seen how with OPA we can implement quite complex policies. I've shown it with Kubernetes in particular, but it can be used right across the IT stack. And we've seen how the Gatekeeper, especially the version 3, provides quite good integration with Kubernetes. Modulo bugs in the demo there. Maybe a Git pull will sort that out. We've seen how Kubernetes can be extended to use these policy engines. That's needed because of the PSP deprecation. On the other hand, as I don't mention here, there will still be some simple inbuilt admission controllers in Kubernetes, but we won't actually even see the alpha version of those until the next Kubernetes 1.22 release in August. Okay, and then so there are several open source policy engines that exist, and then there are also supported product versions of those from various vendors. Okay, so I didn't mention that explicitly. I'll go back there. For Kyverno, the company behind Kyverno, it's open source as well, but Kyverno was created by a company Ninata, N-I-R-N-A-T-A. So they don't provide a supported version of that. Okay, that's it for me. And otherwise, let me know if you'd be interested in future OPA sessions. We could do a real workshop building OPA work use cases, Kubernetes or non-Kubernetes. I intend to propose a Kyverno session in the future, so we'll see how that is different from OPA. I will also be developing at least an OPA training this summer. Okay, and then have some other resources in there. Okay, thank you. Any questions out there?
No questions, Michael. But we definitely need to include the OPA actually in our security classes. So what I'm going to do is make sure that we at least do a simple part of OPA with him, because and indeed you're completely right. The PSPs are going to be often become obsolete. Will take a time before actually they have invented something natively. I really see the power of this. I also see this is quite complex. So in the security course, we need to make this just popping actually. That's what actually can do. So we actually can actually extend a new OPA training, for example. I'm definitely interested in Kyverno also. It should be a little bit more easy and a little bit more, how do you call it? Aligned with Kubernetes. Just for example, that Linkerd is more Kubernetes than Istio is, for example. So definitely, I'm really, really happy and thankful for your presentation, Michael.
Okay, thanks, Pascal. We will talk further on this. I think it would be great in your security course. I think taking OPA Gatekeeper as is, well, if you go with OPA Gatekeeper as is, and then with those Gatekeeper policy libraries as a starting point for the PSP, that's really good.
Yeah, I do really think that our customers need this kind of stuff. Actually, currently I'm busy with transforming from a Docker Swarm cluster for a big ministry, actually bringing them to Kubernetes, and actually it would be really great actually to have the OPA policies in place so that we actually have some baseline to port to. So that would be really great.
Okay, cool. Well, I will definitely share stuff with you as I advance further. Okay.
Good.
Okay, thanks a lot, Pascal. Have a good evening.
You too, many thanks.
Okay.
I will speak again.
Okay, cheers. See you soon.
Cheers, bye-bye.